There are now three possible outcomes. Or let's redefine the random variable of interest. Variable of interest is damages paid per client, and each client has a chance of 10% for an accident, independent of each other. I'm going to actually use these arguments to show you guys that insurance companies are actually in the business of pooling risk instead of taking risk. So what are possible values? Anyone? I have two customers who could both have an accident, and if they do, I will pay $10,000 each for them. Since we're doing it per client, 0. If only one of them has an accident, per client, there's going to be 5,000. Or both of them have an accident, 10,000. Probability of 0 is 81% since they're independent. Probability of 1 is 19%. Actually, no, 18%. The chances that both will have an accident is 0.1 times 0.1. We will normally get these things using Excel functions, but so expected value of X with 0.81 probability, 0, with 0.18 probability, 5,000, and with 0.01 probability, it should not be surprising to you at all that expected loss per person is still 1,000. Next, actually, let's kind of get things set up. Let me put 2 for now. For now, I'm going to do this until, I don't know, 10,000. So we're going to do similar problems until 10,000 customers, up to 10,000 customers. That's considered a pretty large pool for insurance purposes. Okay. Okay. If you have a fixed number of potential events that are independent of each other, and they each have the same probability of happening, if you want to count the total number of events, that's called a binomial random variable. So we're going to, first of all, we're going to say if that number is greater than the total numbers, probability is 0. You can have more than 2 accidents if you have only 2 clients, right? Otherwise, binom.dist, it has 4 arguments. The first argument is what is the total number of events for which you want the probability? What are the total possible value? 2, what's the probability of S, which is called a success? In this case, a success is an accident. The last argument, do you want a cumulative? I don't want a cumulative. I want the probability of exactly that. If you want to type. The only reason this is longer than it needs to be, I'm basically setting up something that's going to handle up to 10,000 without me trying to change things. All I have to do is double click. So if I had 3 clients, probable that none of them would have an accident is 0.729. Only one 0.243, 2 of them 0.027, and so on and so forth. So if I had 10 clients, this will calculate probability of exactly that many accidents for all. Damage per, because that's our variable of interest. I have that many accidents with that much damage, but that many clients. It's not terribly surprising. Oh, I should say if. Not that it matters. If that number is greater than the total. Yeah. So as soon as I tell you the number of clients, this setup is going to calculate damage per client given the number of accidents, okay? Hence, expected value. You multiply probability of that much damage with the damage itself and add them up. And we have the sum product function to do that. Take the damages and multiply them with the probability of getting those. By the way, these are not all zeros. Let's make these general.